This video is intended for maritime students and anyone taking a radar plotting course. Nowadays, marine radars are often equipped with automatic radar plotting aid, known as ARPA, integrated into the radar system. ARPA uses radar data along with computational algorithms to automatically acquire and track targets, providing vital information such as the true course, speed, closest point of approach, time of the closest point of approach, bow crossing range, and bow crossing time. However, this software is not immune to failure. In such cases, the radar can only provide bearings and distances of targets or objects. In the case of ARPA failure, to determine this vital information for collision avoidance, we need the following plotting tools. First, we need to gather the following information, which can be obtained from the radar on board, or from a radar simulator if you are taking your radar plotting course. The own ship's course is 345 degrees true, and the speed through water is 15 knots. We have observed a radar echo, 3 points on our starboard bow. To determine the following vital information for collision avoidance, assuming that our ARPA is not working, we will take the bearing and range of observed target using the electronic bearing line, EBL, and the variable range marker, VRM. Bring the EBL to the observed target, then note the bearing. In this case, the target bears 020 degrees true. Next, bring the VRM to the observed target, and note the range. The distance of the target from own ship is 10.8 nautical miles. This is our first observation, assuming the time is 1030 hours. One observation is not enough to determine the following data. A second observation, taken after an elapsed time, is required. In this scenario, we will use the 6-minute rule. While waiting for the 6-minute elapsed time, let's plot our first observation on the radar plotting sheet. Let's begin by plotting the own ship's course, which is 345 degrees true. From a bird's eye view, this is what the own ship looks like, with the ship's bow pointing in this direction. Plot the target's bearing at 020 degrees, and draw a very light line between 10 to 12 mile range, as the target's distance is 10.8 miles. Next, use your compass divider to measure 10.8 miles on the 12-mile range scale. Then, lay this measurement down from own ship's position, along the 020 degree bearing line, and mark the point. Label this point with a small letter R, to represent the first plotted position of the target ship. We will erase the bearing line to keep the plotting sheet neat. This is now the target's position relative to own ship at 1030 hour. Next, we need to take our second observation, so let's return to the radar. Let's assume that 6 minutes have passed since our first observation. As you can see on the radar PPI, the target's position has shifted from here to here. If the target's bearing does not change, it moves along this bearing line, indicating a risk of collision. Let's transfer the EBL to the target's new position, along with the VRM. The EBL reads 018 degrees true, and the VRM shows a distance of 7.6 nautical miles. This is our second observation, taken at 1036 hours. Let's plot this on the radar plotting sheet. Place the triangle along 018 degree, then measure 7.6 miles, using the 12-mile range scale. Lay this measurement down from the own ship's position along 018 degree, and mark the point. Label this point with a small letter M, to represent the second plotted position of the target ship. Draw a line from R to M, and extend it. Label this line with RML, which refers to relative motion line. This line corresponds to the target's relative vector as seen on the radar. To determine the direction of this line, known as DRM, or the direction of the target's relative motion, drag the triangle towards the center of the plotting sheet, and find the direction below. The DRM is 205 degrees. To determine the CPA or closest point of approach, draw a line perpendicular to the relative motion line, extending to own ship's position. The point where this line intersects with RML represents the CPA, indicating the point where the closest distance between two vessels occurs, if both maintain their present courses and speeds. To determine the RCPA, or range of the closest point of approach, also referred to as the CPA distance, measure the distance from own ship's position to this point. In this case, the distance is 1.0 nautical mile. Whether this 1 mile will be called RCPA or CPA distance, it will appear on the radar screen simply as CPA. To determine the bearing of the closest point of approach, or BCPA, find the direction of the line drawn perpendicular to RML. This direction always starts from own ship's position, and points toward CPA. In this case, the BCPA is 295 degrees. Next, let's determine the time of the closest point of approach, TCPA. But before doing so, we need to calculate first the target's relative speed. The formula is, speed is equal to, distance divided by, time. The distance is from R to M. In this case, the distance from R to M is 3.1 nautical miles. For the time, it is the steaming time from R to M, in which the elapsed time is 6 minutes. But the unit of speed is in miles per hour. So we will convert 6 minutes into an hour. Just divide it by 60, because in 1 hour, we have 60 minutes. So 6 minutes is equal to 0.1 hour. The target relative speed is 31 knots. However, we do not need to go through this process every time we calculate the relative or true speed, as we are using the 6-minute rule. If the ship travels a distance of, let's say, 0.5 nautical mile in 6 minutes, her speed is 5 knots. For a traveled distance of 1.2 nautical miles, her speed is 12 knots. Similarly, if the ship travels 2.0 nautical miles in 6 minutes, her speed is 20 knots. As you can observe, by simply moving the decimal point of the distance one place to the right, you can determine the vessel's speed for a 6-minute steaming time. In this case, the distance traveled from R to M in 6 minutes is 3.1 nautical miles. By moving the decimal point one place to the right, the target's relative speed is 31 knots. For a 12-minute steaming time, simply multiply the speed for 6 minutes by 2, to determine the vessel's speed. Let us now calculate the time of the closest point of approach, TCPA, using the formula, time is equal to, distance divided by, speed. The distance will be measured from the second observation, point M, to CPA, in this case, 7.7 nautical miles. For the speed, it is the target's relative speed, which is 31 knots. Since the distance is in miles, and the speed is in miles per hour, the answer is in hour. To convert into minutes of time, we will multiply it by 60. The time of the closest point of approach is 14.9 minutes. It means that it takes 14.9 minutes, from point M to CPA. Next is the bow crossing range, BCR. This is the distance when the target crosses own ship's bow, or astern. Use the compass divider, and measure the distance from own ship's position, or from the center of the radar plotting sheet, to the point where RML intersects with own ship's heading. Determine the distance using a 12-mile range scale. The bow crossing range is 1.5 nautical miles. If the BCR is negative, the target is crossing astern. Next is the BCT, or the bow crossing time. It is the steaming time from the target's second plotted position, point M, until the target crosses own ship's bow. The procedure for calculating BCT is the same as for calculating TCPA, which is, time is equal to, distance divided by, speed. The distance is measured from point M, to the point where the target crosses own ship bow. In this case, the distance is 6.5 nautical miles. For the speed, use the target relative speed, which is 31 knots. For the BCT to be in minutes of time, let's multiply it by 60. The bow crossing time is 12.58 minutes. So it takes 12.58 minutes for the target to cross own ship bow from point M. This video is divided into two parts. The second part demonstrates how to determine the target's true course and speed. It also covers actions to avoid collision and maintain safe navigation, such as point of execution, MX, where own ship will alter course to achieve a 2 nautical mile CPA. Additionally, it includes the new RML, advanced RML, own ship's new course to steer, and the new speed if the own ship reduces its speed. For the continuation of this video, kindly check the link in the description below.